All right, let's get moving. All right, welcome back. We are COMP1011. That's Advanced OOP with Java in the summer 2022 semester at Georgian College. And it's week 4, part 1 of our broadcast and recording. And just wanted to go over some stuff that we did last week, as well as some stuff that we're kind of covering this week. Hopefully you guys are all doing well. So last week we did kind of an assignment 1 overview, what I was looking for assignment 1. Again, we'll talk more about that today. We also covered solid design principles, what those are, and because we're going to do more design patterns this semester, not too many more, but at least 1 or 2 more. We've also got the singleton design pattern that we talked about last week in fairly good detail in terms of why we would use it, positives and negatives, pros and cons. We implemented the singleton design pattern a couple of times, one for the utility class and the other one for the DB manager class that we created, which is kind of really relevant to what we're doing. We also talked about change listeners and simple lambda expressions last week, and we added those change listeners into the utility class. And then we did some JDBC work, kind of allowing us to insert data into the database, and we also talked about how we can use Maven, a package manager, to download stuff that we need in order for us to have all the components we need to connect to the database. That's what we did all last week. So I figured that was pretty intense in terms of all the stuff we kind of ran, even overtime, I believe, in terms of everything that we had to do. I'm going to try and keep it short. I know that there is an Ontario vote today as well, people who are interested in voting and all that kind of stuff. If you haven't voted already, I'm going to see if I can go as fast as I can, so that way you guys can get out there still. I think the polls are open till 9, and to be fair, I want to make sure that everyone has a chance to do that, which is part of our civic duty. And in order for me to do that, I've just got to go a little bit faster. So in terms of evaluations, assignment 1 is due this week, so this Sunday at midnight, and assignment 2 will be released very shortly. And assignment 2 is, you know what I'm looking for really in assignment 2. Assignment 2 is the persistent data part of assignment 1. And by the way, you'll have most of what you need tech-wise for assignment 2 today. All right, so that means like, how do I connect my database and read from the database for my table view? I'm going to show you how to do that today. That's part of our lesson, and we'll talk about that. As well, one thing to note is if I'm late, and I talked about this last time, but if I'm late producing the in-class exercise data, which is the lab report for you, if I don't have one, right, as an example, and I kind of said this on Discord, but I'll say it with you guys again as well. Remember that I think I'm a reasonable guy. If I don't give you something that you need, then I'm going to give you more time to get it done once I have it, right? So that's how it's going to work for everything, for the lab report, for the assignment, for the lab report, for the for in-class exercises. Anytime you're missing something, if I don't produce it, that's on me, right? But then after I produce it, then it's on you to get it done. And so I need that lab report for your in-class exercises and for your assignments going forward every single time, right? So as soon as I produce the lab report for you, that's kind of like your little rubric. You go through it, it's a checklist. And it's important that you have that to make sure we maximize the amount of marks you're going to get over time. And I've kind of marked assignment in-class exercise 1 and 2 right now. And I noticed some of the same patterns for in-class exercise 1, which was people aren't submitting a valid video. I need to be able to access it with no password, guys. All right, so I need to get at that video and have access to it. Same thing goes with your lab report. I need to be able to see your lab report. It's got to be clickable. Please don't make it a pages document. It's got to be either a Word document or PDF. Those are the 2 options that I'm giving you, right? Something that I can see. It's got to be a separate submission up on Blackboard. So I need 3 things on Blackboard for your in-class exercise. Again, they're worth 3% of your final grade every single week. It's a lot. If you don't do it right, it can really impact your grade, and I don't want that. I want you guys to have good times, right? So what I need is your in-class exercise link to GitHub. Some people give it to me and some people don't. They give me the wrong link, or it's not working properly, or they included somebody else but not me. I need your link to a working link to your video all right? Whether it's embedded in Blackboard or somewhere that's a clickable link that there's nothing for me to download, all right? That's the second thing. And then the third thing is your lab report, right? So those three things, right? And your lab report has to be a separate submission that I can see on Blackboard, those three things. Your GitHub repository should have more than one commit because we're working with GitHub as we go. And your video should have both good sound and I should be able to see the video very clearly. If I can't do those things, it's not really a great video. These are the things we kind of talked about day one. I just want to reiterate them as we approach kind of midterm, because remember that for week 7, there is going to be a midterm practical test that I'm going to give you at the beginning of the week, right? So let's say the Monday timeframe, I'll send you guys all a note, like a Blackboard message saying your midterm has been released. It's going to be a week-long practical test. When I say week-long, it's only going to be geared for 3 hours, just like we would normally do. So even if you have the whole week, it shouldn't take you more than 3 hours to complete it. But I'm giving you a chance to do it anytime from the Monday or early in the week, as an example, on week 7 to the end of the week on Sunday, right? So anytime during that time, you have a chance to submit it. That one is worth 15% of your final grade. It's like a week-long assignment that you'll have to complete for me for this one. So there's no lecture this week. And during that week, on week 7, when we get together on the Thursday, I'm going to be here just for support. So if you have problems, questions, things, you want me to check something, you want to give me a preview of what you got, all those kind of things to make sure that you have a good midterm assignment is what I'm looking for. Okay, so that's what I'm going to be doing with week 7. And why am I mentioning week 7 now when we're in week 4? Because if your in-class exercises aren't working right now with week up to week 4, I'm concerned about your other stuff. Your assignment 1, which is worth 10%, your assignment 2, which is worth another 10%, and as well as your midterm test, guys. And you're going to have the same kind of requirements every single time. So the in-class exercises train you to get everything you need. That's what I'm hoping, so that you can do your assignments very easily. And all the components that you need are there, right? So please make sure that the stuff that I'm asking for is there and complete, okay? So this topic of today, although it's strings and regular expressions, I'm going to also show you how to read from your database. And the reason for this is it'll help you get data from your database. Next week, we'll be talking about input and output, some more data structures, and all that kind of stuff, as well as another tool in your toolbox for your user interface. This week's I'll show you how to kind of connect and create your table view to get that started. And then we'll talk about the graph view as well. And then we need to have a way of switching between one view and another, which is part of your assignment 1 and 2, okay? So Sneh is asking for assignment 3. So I'm probably going to release assignment 3 in week 8. And it probably won't be due until week 11 time frame, in that range. So in the second half of semester. So you got lots of time for assignment 3. Okay, so that is what's going on there. And slowly what we're doing is we're continuing to add more functionality to that little app we're building. It's a little contrived, the little vector app. And like I said, I'm hoping that we're going to actually see some drawing at some point in the future. But for now, we just want to add some data points to the database. And that's what we're going to do. We want to read them. Last week, we added them. We're able to add them into the database. And this week, we're going to read them from the database and populate them into a table. That's what I want to try and do with this in-class exercise. So it should be fairly straightforward. So again, this week, I want to cover strings, some popular methods that I'll talk about with strings, because you're going to need strings and string manipulation and all that kind of stuff. Because remember, whenever we get anything from the user interface, everything is a string, okay? It doesn't matter whether you're using Android or iOS, or you're developing stuff for Windows forms or the web. Any kind of input normally that comes inbound from a user interface, a lot of times is a string. And we need to be able to manipulate that, convert it, validate it, all those kind of things. And so we got to talk about some user validation And part of that is strings and regular expressions, which is the topic of this week. So this is kind of our theoretical topic. And then we have a table view that I want to do, more JDBC and so on. Stuff that's due. Assignment 1, like I said, is due Sunday. ICE 4 right now, until I get the lab report done, is due Saturday. Worst case scenario, if I don't get it out to you by tomorrow, it's not really fair. I try and give you at least a day to get it done, but you should follow along with me today. And if you'll have most of it done by the end of today, and then all you need is to attach your lab report, make your video. Worst case, if I can't get it out by tomorrow, then it's going to be due on Monday, right? Because I don't want it to clash with your assignment 1. Okay, I want you guys to have all the time you need on the Sunday to get assignment 1 done. You should be mostly started with assignment 1 already. And all that kind of stuff. And assignment 2 details will also be out. Assignment 1 lab report, which is basically your rubric, is also going to be out. My plan for that is for tomorrow as well. So why the lateness? Because people ask me, like, you're delayed and you're doing your lab reports and stuff. I'm making it up, guys. All right. It's not, no one's giving me this information. It's not like it's something that I'm inheriting. Some parts of it is because I'm working with Jarrett and other people, but my class is very different than the other course, the other section that's going on right now for what they're doing. So again, we have very different ways of doing things, and so bear with me. I will get it out, and then you're going to have something that's fairly descriptive enough. I think you'll find. I'm not sure how you've been finding your lab reports, but they're not that difficult. It's literally a checklist. You go through and you go, okay, I did this, 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 this. Here it is, Tom, and see you later. And that's what I'm looking for. And you guys, for the most part, I would say 80% of you at this point know how to do that, okay? There are still some 20% of you that are either not submitting things properly or it's incomplete for whatever reason. All right, so that is what we're doing this week. Any questions before we continue? Because I want to get moving on this. And like I said, I don't want to make it last all night tonight. I want to give you guys some time to, if you need to go vote for whatever you need to do. I think voting is open until 9, so we want to have to make sure that everyone has time to do that, if you're someone who can vote or who is interested. All right, so let's move into some stuff that I want to talk about today. So I'm going to talk about fundamentals of characters and strings and so on. Remember, you guys have done characters and strings before. This is not something new, right? Is there any report for assignment 1? Yes, there is, Nitin. I will produce it for you. So it's not like you don't know what character literals are and all that kind of stuff, okay? My expectation is when you're doing advanced OOP, that you understand what a string is and that you understand what characters are and that kind of stuff by now. I'm not going to go into too much detail here, but there are some differences between the way Java handles strings and how you might learn to handle strings in other programming languages. For example, if you've programmed in C# or in C++ or in Python or in JavaScript or any other language that we program in together, then Java handles some stuff in slightly different ways. And so we need to know what it does. So one thing to note is that a string itself is an object of the class string, capital S, right? And string literals are stored in memory as string objects. I think those are kind of some key learnings here, this line right here. And so when I create a string, as an example, remember that there's many things that I store. I store the actual value of the string inside of the object, the value, whatever that is. And the string value can be broken up into a series of characters. Each character, it's almost like an array of characters, I think is the typical scenario, the typical way we think about a string. And the one thing to note is that strings are immutable. Immutable. That means you cannot change a string once it's been created. Sorry, Nitin says, sorry to interrupt, sir, but already submitted my assignment 1. No problem, Nitin. You can always resubmit with your video, with your lab report. Okay. All right. So let's keep going. So when we compare strings, one thing to note in Java is there are 3 primary ways I like to say to compare strings. One of them is using the equals method of a regular string. The other one is the equal operator, and the other one is the compare to method. And in some languages, like for example JavaScript, it's okay to use the equal operator. Actually, there's 2 operators you can use in JavaScript. You can use equal and triple equals. Does anyone remember if you're a JavaScript person, do you remember what in JavaScript equal the triple equals means? Anybody? There's actually a thing. So if I type in triple, Nitin says strict. Yes, it is strict. Kuhan says strict equality. I like to think about it as exactly equal. And what I mean by that is equal means it's not only equal from a value perspective, but also from a data type perspective. That's what we do with equal in JavaScript. And you can compare strings this way, no problem. If I have a variable that's holding a string type variable in JavaScript, it's nice. And you can do the same thing with C#. C# is very polite and flexible in terms of comparison. However, you'll notice that if you try to do equal with a string object and a string literal, it will fail. Why would it fail? In Java, I'm talking about. This is a review, by the way. You should know how to do this already. But why would it fail? What does equal do for us in Java compared to what it does in other languages? Does anyone have an idea about this? So if you tried to compare a variable, right? Yes, Guhen, you're actually correct. So it's a reference. It compares references. It does not compare values. So this is a really much different thing. If you try to do an equal with a variable and a literal example, if I make a new string and the string is, I make a new string called hello, and I use the constructor for the string equals to new string, and I make a, I pass in hello parameter. We're going to try this now. You're going to see this in a second. It's going to fail if I try and compare them with equal. So equals makes more sense. That's one thing. And the other one is compare to. Those are the three types. Equals, what it does is it basically it returns a Boolean. You can put in the other string in there. You can also equal and ignore case if you don't care about the case. That's another variant of equals. And once you use the equals method to compare strings, which is kind of, I would say, fundamental to do any kind of thing at all, you put the string in there, and then you can compare the current string with the other string to make sure that the values match. That's what equals does. Equal, and here's the example. If I had a string that I said S1 is the string, and I have a new string and I pass in a parameter hello as an example, and if I try and do a comparison, like if S1 is equal to hello, or if I try and do a ternary operator, if I'm using a ternary operator to do a comparison, this would fail. Okay, and the reason why is because S1 is an object, and when we use equal, we're comparing references or memory locations. And when we do that, hello, which is a string literal, is being stored in one memory location, and S1, which is a string object, is being stored in another memory location. And because the memory locations are different, this will fail. All right, so it's not going to be true. And that's fundamentally different than in most other languages out there, if you compare these two things. So be careful about this. One thing to note also is that each character in a string computes to some kind of integer, which is a Unicode, kind of integer, kind of compares. And I can also do other comparisons like greater than or less than with strings. And so I can do things like, well, this one is greater than the other one. What would greater than or less than do? What do you think that would do for strings as well in Java? Do you guys know? Do you guys remember? You should know. If I put greater than, this string is greater than, I make a comparison with the other one. What am I comparing when I say greater than? It's not memory locations anymore. I can tell you that. Compare the Unicode characters. Exactly. So if I add up all the Unicode characters, I start comparing them, right? The value. And then I can tell if one string is literally coming after the other one, or before, or whatever. And it's a way of us organizing or sorting, as an example, alphabetically. So it's really about alphabetical order. So that is the equal operator. It compares references and not values. The other one is the compare to method. And the compare to method compares values, what it's called lexicographically. Woohoo! I'll be okay. for today.
Which phone number,
See, look,
contact, or device do you want to call?
whenever I do that, my friend Alexa always goes
Calling phone.
crazy. Don't call anybody. How about that? Alexa goes crazy when I do that kind of stuff. All right, so yeah, so what it does actually compares to another string, and then it returns a value to describe if the the string values are equal, it returns 0. If it's greater than, it returns a positive value, and if it's less than, it returns a negative value. I'll be honest with you, I prefer compared to rather than less than and greater than when I'm comparing two strings, because then I know for sure that I'm getting a positive or negative value based on their um, on how they form out. Okay, so just letting you know, this is kind of a better way, in my opinion, to compare two strings if I want to make them equal or whatever compared to the other ones. Although I have to say that I really like equals as well because it's very straightforward. Okay. So string comparisons is the beginning of us talking about other popular string methods. And I've included it here in the PowerPoint. I don't expect you guys to be able to see it very, very clearly, but there's a bunch of really popular methods, I would say, that are required. One of them is character at, concat. We concatenate two strings together, contains. I have a character sequence and I want to compare or check to see if the string contains. Using a contains method is really awesome in that you can actually compare to see if a string has values. You can do a search. Ends with, which is like, does it end with a suffix? Format, I can use a format in some kind of format specifier to format a string a certain way. Index of, I can find the index of a substring. Is blank and is empty, I think, are very, very good ones. The difference between is blank and is empty is that is blank also compares white space characters. It basically says if there's only white space characters, then it's blank. Okay. And it's kind of like being empty. It has a, kind of a length of 0, or if it has just white space or tab characters, then it's blank. All right. Which is kind of really cool. I think it's a good use. Join, when we want to join a bunch of a character sequence with some kind of delimiter, for example, comma. I want to comma delimit a bunch of values, and I can return a string, a big string. Length, of course, makes sense. Matches, which is what we're going to use today with regular expressions. Replaces a old character with a new character. Splits. Again, we use a regular expression to find the string, and then we split the string at that point with a particular limit. Starts with a prefix strip, where I can strip out leading white spaces from a given string, which is kind of a neat thing. It's almost like a trim function, which is kind of cool. Substring creates a new string from the beginning to the end, which is, we use that a lot when we do manipulation a lot. Two character array, which I find is very nice. In other words, it creates an array of characters as opposed to just leaving it as a string. And once we have an array of characters, I can do manipulation on that as well. Two lowercase, two uppercase, and value of, which basically returns the string literal, the character array of a string, whatever the data is of that object. So value of the character array back out. So converts to a character array and returns the character array back out as a string, which is kind of neat. Okay, so most popular string methods I've listed here. The other one is StringBuilder. StringBuilder is an alternative, I would say, to the string class. So what we're going to find is that with StringBuilder, strings are immutable, but StringBuilder creates something that is mutable. So you can actually modify a sequence of characters with StringBuilder. You kind of use StringBuilder in the same way that you would use a string constructor, right? But here what you would use is there's 4 different constructors that you can create with StringBuilder. The default constructor, which makes a string builder with no characters in it and an initial capacity of 16 characters by default, which is kind of neat. So that's how many characters it's going to have. String builder with a capacity that you can specify. String builder with a character sequence that you want to enter. String builder with a string that you want to start things off with, an initializer string. And then popular methods that you would use with string builder compared to the string class is append, delete, replace, and reverse. And again, there's a lot of other things that you can do a lot of the same methods that we've listed here are also possible with StringBuilder. So StringBuilder is just an alternate on making it a little easier for us to use strings and manipulate strings. Okay, so a couple of ways of doing it. And that leads us right into regular expressions. But before we get there, any questions around strings? Have you guys had trouble at all? And we have to cover this because at the end of the day, strings are handled a little differently in Java than they are in other languages. I'm mentioning it that here so you know, but we're not actually doing a little tech example yet. We're going to do that in a few minutes, but I want to make sure that you guys know kind of the foundation of this stuff first. So any questions around this, or are we good to continue? Hopefully you're good to continue. Great, thank you, Nitin. All right, so, but regular expressions are kind of baffling for some people, and we're going to make some. What I want you guys to do to practice with me is I've given you a link, which is regex101.com. Please go there. I'm going to give you this little online little platform that allows us to check. And I've kind of entered a regular expression. We're going to build this regular expression together in a second. And we can put different numbers in there and stuff to test things out. One thing to note is that regex101.com has a bunch of ways of checking things out. For example, if I'm using JavaScript, I might want to check off the JavaScript or ECMAScript option here. That's the flavor of of regular expressions. One thing to note is that regular expressions are the same across most languages. So if you know how to use regular expressions here, for Java or C# or JavaScript, they're the exact same. All of them are pretty much the exact same. And I think as a quick reference, this is really cool down here. It kind of shows you a reference, common tokens and meta sequences and stuff. You and I are going to learn how to write regular expressions today a little bit. And why? Because I think it's really great when we want to use regular expressions to compare input from a user, so some kind of user input, to what we expect them to enter. Okay, that's kind of something we're going to be doing. All right, so that's ECMAScript. And this is where we're going to start entering our regular expressions in a second. But what are they? It's a search pattern. I think it's kind of the simplest way to think about regular expressions is that they are a search pattern. Have you guys done regular expressions before? Because regular expressions are covered in other languages, not just in Java. Yes, no, maybe. If you say no, it's okay. So, guys, anybody? So, okay, you guys are saying no. Oh, so I'm the first? Ho ho! But you guys are in for a treat because regular expressions are kind of ugly when you look at them for the first time, and we want to practice with a little bit with them. What they contain is something called meta characters. So when we start looking at a regular expression, it might look like this. And when you look at this regular expression for the first time, you're like, what the heck is this stuff? It's crazy, right? It's like no one understands what it is from the beginning. And this is an example of an email matching pattern. Try this out. So try and take this regular expression. I'm going to kind of copy it here, put it on the chat for you. Here's the regular expression. And I want you to take that thing and let's see if we can put that in, our regex 101 online here. Let's kind of populate that in. Make sure you've chosen Java 8 as your flavor. Doesn't matter which Java, but any Java 8 as your flavor. And on the left, you can see that I'm using the match function, right? And it's basically saying if you hover over any of these characters, it tells you what they do, which is kind of neat. It says that the caret asserts the position at the start of the string. So at the start of the string, this is where we're checking this part. And square brackets like this basically says we're going to match a single character. So this part right here, from here to here, it matches one single character, which starts off with an underscore, an A to Z, lowercase characters, A to Z, capitals, 0 to 9, and we're looking for one single character, and it also could include a dash. So a dash is another thing that it can include here. So those are the different things that it can have, all right? And so if I start typing, and if I start typing a character, any character, like for example, A, right, as an example, well, shouldn't it match this? Well, maybe it matches one single character, but that's the first thing. If I start typing and it says plus, there's a plus, and plus says matches the previous token between 1 and unlimited times, as many times as possible, giving back as needed. So that is what it needs. Okay, and then square, which we'll call it round brackets, is this capturing a group. So this is almost like a sub-expression. That's what this is right here. And we'll go into it in a second. Slash is an escape character, right? And it says dot, so something dot, so one or more. It says one or more of these, matches the previous token 1 and unlimited times. And then a dot potentially is what we're looking for. And then we're looking for square brackets, a character, at least one character that is underscore A to Z, 0 to 9, or a dash. And then, like it says, matches the previous token but 1 in unlimited times. So at least one. So it could be A.A, something like this, right? And then it says star. And star says matches the previous token between 0 and unlimited times. So at least 0 times for this one. So it could be A.A or A.A at. So that at sign is required because there is no option for it, all right? And then square brackets means a single character between A to Z, 0 to 9, blah, 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 blah. And that's 0 to or 1 to unlimited times. So let's say A, I'm just using the same character. And then in brackets, it could be at least 0 or more times, right? That is required, 0 or more times. And then dot, some kind of dot down here, which is this is required. And then 2 to 6 characters in length. From 2 to 6 times, I want to repeat, that is square, curly braces tells me I need a quantifier of at least 2 characters to 6 characters from A to Z. Okay, so let's say dot com. And you can see that it matches now, and it says on the right, it says matches 1, 0 to 9, 8a.com, group 1, 1 to 3.a, and group 3. So these are different parts of the sub-expressions that it's matching. But you can see that A.A at A.com matches. Now, that's interesting. We can also say A.A.A.ca. That also matches. But A.A.C does not match because you need at least 2 characters. Okay? So we're going to use this testing string. And remember, one thing to note, I want to talk about this a little bit, is even though we have this expression for email, we're going to build this in a second for a phone number. Remember that the more strict you are, the more exclusive you're going to be when your user enters data. For example, maybe this doesn't cover everything, right? And we're going to talk about what it covers and what it doesn't cover. Sometimes we want more flexibility with something, maybe even the ability for us to make mistakes with entry compared to too strict, because too strict is exclusive. It'll exclude certain users. As an example. And too loose will be like not having anything at all, right? So we have to find a kind of a balance between how we're going to get data in. Let's say we're looking for an email address that looks something like, at least something like this, right? And .ca. But does this make any sense? Can I have a name, a domain that's only 1 character in depth? And I would say no. I would say you need at least something like 2 characters, at least. For example, something like, I don't know, a 2-character domain. I mean, I don't even know what that would be these days, right? No one has really a 2-character domain. Usually there's 3 characters or more. IBM, as an example, ABC, NBC, those kind of things. It's rare to see a domain that has only 2 characters. Maybe xc.com. When they first came out, the top-level domain was available. Now it's impossible, right? So rare to only see 1-character domain. So that is what we're looking for. So we're going to talk about this. Let's go back to our little PowerPoint and see. So this is the email matching pattern, and we're talking about meta characters here. Meta characters, and I'm just going to zoom in here so you can see this. Meta characters are interesting in that they have a dot, which is matching any single character. That's what dot means, right? Slash, which is a backslash, goes from the top left to the bottom right, identifies the next character as a literal. So it's kind of an escape character. Caret, like we saw, matches characters at the beginning of the string. $sign matches characters at the end of the string. Parentheses specifies required characters to include a pattern match, almost like a sub expression, if you will. Square brackets specifies alternate characters allowed in a pattern match, only one though. And square brackets with a caret specifies characters to exclude in a pattern match. So I don't want some character, whatever that is, right? And then the dash identifies a possible range of characters to match. And a pipe character specifies alternate tests that you can do, either this one, this set or this set, but not both, or either or, basically. So that's kind of neat. So the first part is meta characters. That's what we're looking for, meta characters. Let's try and see if you and I can put together the beginning of a phone number. Okay, so with just this part, right? So again, if you think about a phone number, and let's just get a test number in here, and we'll use a 905 or a 705 number, doesn't matter. Let's use a 905 number. So let's say 905, this is our test, 555, 5555. Okay, you can see clearly that the email expression doesn't work, and we'll get rid of it all. So goodbye, email expression. Let's start writing. So I'm looking for basically 3 parts of my phone number. And if you think about it, there's actually a 4th part, which is the international piece. So 01 would be, kind of North America. And a lot of times we also have a plus, something like +01, and something that looks like this. Would you agree? Would you say that this would be an international number that's at least, would I need more for my international digits than just 2? Is it 2 or 3 now for international digits? 3. Okay, so maybe it'd be 001, right? That would be the thing that I need. 001, right? 905, 555, 5555 would be something that we would need. So that's the test number that we're going to use, okay? And some spaces. I put these spaces in here because we want to do that. So the first part is going to be a plus. We're going to say, well, we need a plus, right? And the plus is a literal, so it's got to be backslashed. It's got to be escaped. So that's the first part, right? So you can see that backslash is always an escape character. It says that plus is this, okay? Again, we're focusing on the Java 8 type over here. And the next thing is, for this whole piece, this whole thing is a sub-expression. Sometimes we have an international calling number, sometimes we don't. So we want to make this whole thing optional. So if I take this whole thing and put it in brackets like so, then I can say that the previous one is optional. So remember that we said, if I go back here, dot matches any single character, and we had some other ones, a quotation mark and a star. So a quotation mark, what does it say? It says matches between 0 and 1 times, as many times as possible, giving back as needed, right? There's also a star, right? So there's that one. Star says 0 to unlimited quantifiers. And the other one is, so we have star, we have a plus. We have a plus, right? So plus, and plus says at least 1 time, all right? So it can't be a plus because plus, the symbol plus means at least 1 time it's a quantifier, 1 or more. And by the way, quantifiers are also here in our little PowerPoint. Quantifiers tell us how many things we need. So question mark, plus, and star, right? So if I need 0 to 1, I'm going to use a star. That's what I want. So I want at least 0 to 1 of those things, okay? That matches. And inside there, we're going to say at least 3 characters. So anywhere between, it's got to be 3. So I can say I need 3 characters from 0 to 9, okay? So let's say, here's my range, and I can say 0 to 9, 0 to 9, and then I want to say that 0 to 9, I want to have at least 3. Would you agree that that would be good? And then you can see that that matches the first part. So square brackets means I need a character, a single character between 0, dash means a range, 0 to 9, and curly braces mean that I need 3. That's a quantifier. Again, quantifier is here. It tells me a minimum range, right, that I need this many times. It's going to repeat exactly this many times. All right, cool. So that's the first part. Okay, so that is 1. So 1 is, I'm definitely going to need this. If I have this, then I either need a space, a dash, or a dot. Those are things that we've seen in the past. Space, dash, or dot, right? If I have this. So that is a character that I want. So again, square brackets again. And I want either a space, which is S, right? A dash, right? So a dash character or a dot, one of those three characters. And or nothing, none of those. Space, dash, dot, or nothing. It's just like butted against the whole thing. And this would be, of course, optional, right? Because we're going to say that is, I want 0 or more of those, right? So if I was to do something that looks like this, it would also be okay. If I did this, that would be okay. And if I did this, that would be okay. But if I did something else, that would not be okay, right? So space, dash, or dot. Those are good, okay? Let's use a dot or a space for us, okay? And that would be the first expression, okay? How are you doing with this, guys? Are you getting it? So again, what we're doing is we're identifying what characters we're looking for. This is our test string as we're continuing to include different things. We've already done this part. So again, square brackets means I need one character from 0 to 9. By the way, I could also put another way of stating this is I need one character that is a D. D means it's a character class, which is just digits. That's what /D means. And if you look here, I've also included those here as well, which is our character classes. So /D means digits only. /D means non-numeric characters. So anything else other than numeric, it excludes digits. /S is a white space character. /S means all printable characters excluding white space. /B is a backspace character. /W is any character that is not alphanumeric. And /W lowercase is alphanumeric characters only. Okay, so that's like no symbols. Okay, so pretty cool in terms of we can use these to save us to say something like A to Z lowercase plus A to Z uppercase plus 0 to 9. That's all alphanumeric characters, really what we're looking for, and that would be like /W. That would be like a step to save us, when it comes to that. All right, so that is what we're looking for here. So that's /D instead of 0 to 9, which makes sense because you can have all these. How about this next one, 905? Well, we know it's an area code, and the area code is required nowadays for when you do something, right? Maybe your country code, if you're outside of the country calling in, is optional. But area code, I don't know. I think to me that's kind of a requirement these days. So what I would say is I need a subexpression. Here's my subexpression. And my subexpression is going to be at least 3 characters that are numeric, right, is what I need. So again, I'm going to say the same thing, /D, right, and I need at least 3, right? That's what I need. That's the second portion. That's second group. Notice it says there's group 1 and group 2. Group 1 is this first expression in the green brackets. Group 2 is the second expression right here, okay, that I'm using. So I'm substituting. I'm having second expressions. Now, I could also include in group 2 some kind of spaces, dash, or dot, and I'm going to take the exact same structure that I have here and put that in group 2 so I can include that space, dash, or dot. All right, that's what it looks like. Followed by 3 characters, again, with the same thing. So I could come almost like duplicate this thing. I need these, though, so I can't skip them. All right, I need at least, there's only ever 1 of these. Okay, I don't need 2 of these. So it would have to be the second part. I'm kind of duplicating the next little part here. This is the third capturing group, okay, like it says. And I'm going to have these 5, 5, 5, 5, and followed by, as an example, the fourth capturing group, right? Which would be, instead of 3 characters, it would be exactly 4 characters in length. Does this compute? How does this look to you? How are you feeling about this? Are you guys good with this? Let's do some other tests here. Let's see if we can put it in some other ones like 416, 555, 5555. And what you can do is you can add switches. So you can see that as an example, what I want to put in is some flags. One of them is multi-line. Multi-line will actually allow me to look at multiple lines. That makes sense. So if I do something like this, right? And the other one is I can also use something called global. right? Global means don't return just after the first match. Tell me how many that you have, right? So you can see that this is clearly okay as well. It captured the first one. It kind of connected those two together, right? It said this one and this one are the same. This one and this one are the same, and this one and this one are the same. Why? Because the first one is optional, and I don't have that plus with 001. That's kind of the configuring mark to make everything good. All right, and I can also do 416.555.5555. That's also good. And I can also do 416 space 555 space 5555 or 416 dash 555 dash 5555 or a combination thereof. But what I can't do is I can't do 416 555 5555. That I can't do, and that's the only one that I haven't covered. Let's see if we can do this one as well. So in the next group, which is this one right here, we have options to have brackets, an open bracket and a closed bracket. Now, this is kind of interesting because if I have an optional bracket, it's going to look like this: slash open bracket, which means an optional bracket, right? And then at the end, right? At the end, slash closing bracket, which is an optional closing bracket. Slash means an escape character, right? So again, slash is kind of saying that the open bracket is optional, and the closing bracket is also optional. Okay, and we want either this one, this pattern, or a pattern that does not include, the closing brackets. Okay, so it's either this one that you must have this bracket. Notice that it's required in this case, and these ones don't match, right? Only this one matches. Or I can say, remember the pipe character? I can say it's either this one, or let's add in some other ones. Let's add in the same thing, right? So this part right here, we'll kind of copy this one. That's a pipe. Or we don't have the open bracket, closed bracket deal, right? Where we kind of remove the closed bracket altogether, which now matches all of this. Okay, so we can either do this one or this one or this one, but not this one. Huh, why not? How come it doesn't do this piece? How come it did like these ones, and it kind of matched this one, but not those ones? And it's kind of like it didn't see that this one here is either this one or the other one. And again, it's kind of hard to see because it's all color coded and everything else. But okay, so Nitin says there's a dash that's missing. Okay, so how is that possible? Because this is kind of multi-line and everything else, and I don't understand. What do you mean? So let's go over it again. So if this part here is supposed to cover, and this star means that this part here, this part is saying that it covers this piece. Okay, so that's what this one. So by itself, it was working fine. But then it says followed by this open bracket slash and this part, right? So it's either this one and then the pipe followed by 3 characters and then, dash and whatever, and that's optional. But this says it's required. So it's either this one or this one that's required. Should I put this in other brackets? So let's try it. So if I bracket it off again, so if I say bracket there and a bracket over here, I'm just putting this out there to you. Now it captures everything. Why? Because I'm using subexpressions of subexpressions to make sure this is working. So this is where it gets a little bit confusing. When you first looked at it, I'm sure when you looked at it for the first time, guys, you were like, what the heck is this regular expression? It's a match. It's a matching pattern. And now you can see that this is okay, this is okay, this is okay, this is okay, or even this one, right? How about if I tried doing the other one? What if I said something like plus 001 and then space 416, and then 555, 5555. Is that okay? And that works too. right? That's okay too. Or I can replace the spaces with dots or dashes, right? I can do that if that makes more sense to you. Or I could do this, which is something that makes more sense to some users. That's okay too. Or all those are good. Questions around regular expressions the way we've done them right now? Any puzzling things that we've done if you're looking at this? Because I will ask you at some point to use some kind of validation, right? And we're going to ask you to use something like, hey, enter in the username, enter in the password, enter in some different things that I want you to check for. And you could certainly use if else statements, but this does a lot of stuff all at once. It's checking a string out in one line of code, which is actually a pattern that we're using here. And this pattern, guys, I'm telling you, is universal. It works well for all of our programming languages: C#, C++, JavaScript, Python. It works for everything. It just has some slight different syntax from a secure perspective. Notice that I use question marks for Java, and for JavaScript I use slashes, the first and then there's slashes at the beginning and the end, kind of stuff. And I also have to use slashes in between. For this dash, notice that the dash does not compute. I'd have to use a slash as an escape character for the dashes as well. So that's something that's just not computing here in terms of our dashes, right? That's where we need those extra escape characters, right, for ECMAScript. Java works either with them or without them. C# doesn't really compute at all for any of this stuff because it's missing some additional things. So C# has some other requirements, right? PHP, again, works no problem at 7.3 and greater than 7.3. So Python, we're good to go, right? You can see that Python adds R for raw, right? That's the delimiter. Golang does work as well, and Java works. So it's pretty good in terms of everything. So any confusion about this at all? I know it's hard to do, but I recommend try it out. This is our expression for our phone number, right? And that's area code, so country code, area code, MPF, and I think it's MPX, as well as our local number, right? So that's the way it works. So that's for phone numbers. And I've given you some examples here. If you scroll down, I've given you some examples for email address and phone numbers, as well as other things, okay? And some of them you may disagree with. Like, for example, this one, I totally disagree with this one. And the reason why is because of this 1 to 2 characters for country code. It's usually 1 to 3 characters, right? Email address, the problem with email addresses are, it depends on how you see email addresses. I've never seen a single character for an email address. Password strength is interesting, where you have at least one lowercase character, one uppercase character, one number, and at least 8 characters long, right? So that's something you can also test with. And same thing with username, where you must have an alphanumeric string that may include an underscore and a dash having a length of 3 to 16 characters. So that's kind of some common things that you might see out there. Let's see if we can do an email address, and then we'll stop with this example. So let's do our own email address now, and let's start over. So this is what I recommend, something like this for a phone number, right, for us. So this is the one that I recommend. So this is the regular expression we can use for a phone number. It looks baffling when you first look at it. It's almost like overwhelming. But we want to test a couple of things out here. So let's test some. This is our test string. And we'll start off with the very basic things. Probably there might be a person that has a name like Al, like Alan, cut down, and they might have at their company name might be something like 2 characters long. Like, for example, I don't know, HP. There's something that might happen, right? And let's suppose HP had a Canadian outfit out here somewhere. Then it would be hp.ca. That would be the lowest or smallest amount that it would be, right? So again, let's try this out. So we're looking at trying to match the first part, the second part, third part, and so on. We know that it requires we must have an @ sign for all email addresses. So we can start with that, actually, right? We know the last part after the @ sign must be at least 2 characters that are alphanumeric. So both numeric characters and alpha characters, okay, can be in here. I've never seen a character like 2 numeric characters. I've never seen that. Like, for example, if you try something like x1.com, right? Maybe you'll get something like x1.com, but I've never seen something like 1x.com, right? Maybe there's something like that too, right? And yeah, 1x.com is valid too. I'm just randomly choosing stuff. So either one is good. But what about, 12.com? Is that even a thing? Can you do that? Yeah, you can do that too. 12.com. Look at that, right? So all of those things work for what we're doing. And this is kind of part of our testing, which is what we want to try and do, is kind of confirm that all the things that we need to do are working. So we need at least 2 characters, alphanumeric. So again, for us in this part, right, which is what we're testing, after the @ sign, we're testing for at least 2 characters, right? So, and it must be alphanumeric. So we're going to say something like a character that is alphanumeric, right? So that is, it says, matches any word character A to Z, 0 to 9, and underscore. I don't know if the underscore would be good, but it says any word character, any equivalent to this. Well, check this out and see what happens. If you really want to be specific, you could put in, A to Z, 0 to 9, right? That's kind of equivalent to that, right? And then we can say something like at least 2 characters, at least 2. So that suffices. That's good. Followed by a dot, that is required. So there's no options there. Must be a dot. Followed by at least 2 characters that are alphanumeric, right? So again, I'll grab this same string here. At least 2. I've never seen 1. At least 2, that are alphanumeric. So that whole last part is good. But how many characters max? There's a maximum of how many you can put in here, not just a minimum. Be careful, right? Because if you think about what this means is there's lots of little subdomains. One way to check this is GoDaddy, right? If you're going to kind of look and see subdomains for an email address, you can look at GoDaddy names right now and what they're offering, right? So a lot of times, no, I don't want to sign in. I just want to test GoDaddy by myself. How about that? I have a GoDaddy account, but I'm not going to use it. So let's do a domain, like, for example, my funny domain, right? That's okay. That's allowed, right? And you can see that it says myfunnydomain.ca, myfunnydomain.com, right? But they also have .store. So that's 1, 2, 3, 4, 5 characters. .shop, .tech, .live. And there's a bunch of other ones that are 5 or 6 characters. So there's like 5 today, right? And that's new. Online, there we go, there's 6. So it looks like probably 6 would be the max. Oh wait, I'm wrong. Properties, that's a new one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa. So a 2 to 10 characters, I don't think I've ever seen that long before. And again, you could search it up to make sure what that is, but that is pretty long. And that means that in a regular expression, we'd have something like 2 to 10 characters in length. Anything greater than that would fail because we don't know anything that's greater than 10 characters. It would probably be an invalid email address. All right, so al@hp.ca, the last part is working okay, but the first part has to be at least 2 characters, and they must be alphanumeric. That makes sense. So again, I'm going to grab this piece right here, right, as an example. And I'm also going to put those characters in there. So now it matches this pattern. But what about if I put in something like, tom.smith@hp.ca? That fails, right? So you see, like, the first part is no good because I'm actually adding in the first part with a dot, and then something else, right? So we have an optional part at the beginning, right? An optional part at the beginning. This is our optional part with an optional dot in with it. So it's going to be some kind of dot character and that whole part is optional. So this part is optional, right? And we want to have at least a couple of characters here. So again, it'll be A to Z, A to Z, 0 to 9. Oop, that's the character, and at least 2 characters. Oops, like so. All right, at least 2 characters. And now, and it says 2. That's exactly 2. And so is this. This is exactly 2. At least 2 is 2 comma, right? And same thing here, 2 comma. And, that's kind of at least 2 characters. A to Z for the thing, for the domain, if you want more than 2 or more, is 2 comma, with me not having too many matches. So if I kind of hover over here, it says 2 and unlimited times, at least 2 characters and unlimited times, right? At least 2 characters unlimited times. Again, this may not be accurate because there might be limitations on how long my actual email address can be, right? But the more limiting we are, the more it's exclusive as well. So that's tomsmith.hp.ca. But we can put other things too, like, Joe5 at, hp.ca. That also computes, Joe5, right? Or Jojo, .joe, right, at hp.ca. That also works, right? Jojo.joe. What about if someone has a middle name, like a couple of, I've never seen that before, like another dot or a dash or something else like that. An example would be Joe underscore dot Joe at hp.ca. That works, but the underscore does not if they have an underscore. Like, for example, Joe underscore 123 is okay, right? Joe underscore 123. But Joe by itself, like this underscore, does not work, right? So this is where we can try putting in that other remark, which is something like, I want to have in /W. And now that would work. Joe underscore would work by itself. And could I have a Joe underscore as well? Probably, right? So I would say that this could be probably a /W as well. So a bit of a refactor. And HP, I've never seen an underscore in there, but what about dashes? So what if I put a dash in here as an option? So example, if I had something like, tom.smith at my-computers.ca, right? That doesn't compute. That doesn't work, right? This fails because something having a dash in here for the actual domain name doesn't make any sense. Or how about underscores? Is underscore okay? Underscore works, but that last part doesn't work anymore. So this part right here, which is before the 2 to 10 characters, it's got to have more flexibility. So we definitely want underscores. So that is definitely a thing. So we want that underscores to work, right? So that alphanumeric stuff is okay, right? And what about dashes? So if I said something like, well, a dash is also an optional character, right? I want dashes in there too. And dashes seems to work okay too with alphanumeric characters and dashes. But the thing is the CA doesn't work. So we have to say that the character could be any of these or a dash character, which is /dash. It could be including a dash character. And what about if the person's got a name that is hyphenated, right? Because they have 2 or 3 last names or whatever it's going to be. That's also possible. So we have to be flexible there too, which means we need to include a dash here, right? So that could be something. Like, for example, something like Tom, St. John Smith .my.computers.ca. That should work too. Somewhere like at maybe would be nice. Like that. That should work, right? And that can be something that might work on an email address. So you can see, like, we want to be as flexible as possible. Thoughts, guys? I don't want to spend too much more time talking about regular expressions, but I want you guys to see the patterns that we're looking at here. And you should be able to puzzle it out if I was to give it to you, even using this site. If you use this site and it gives you some examples here, you should be able to write it from scratch. If I'm telling you that you need to write it from scratch, there's got to be a reason. Maybe a test, coming up that might ask you to write a regular expression to do something. So I need you guys to be a little bit acquainted with how it works, what it looks like, and how to write it. Does that make sense? Anybody? It might be. Is all I'm saying. It's important to understand how this works, because once you know regular expressions in Java, you know regular expressions for everything. Once you've learned it once, and if you know it well, you shouldn't forget this thing to use regular expressions later on. Okay. All right. Remember, flexibility is a key, because if I was to cut this down, if I said something like, I need at least 3 characters for my first name, then someone like al.hp.ca wouldn't work. That means like they would just say like my email address doesn't work. And by the way, one other thing we do when it comes to email addresses actually do the testing. We can actually go out to the web, and there's some services out there that can just check to see if that email address actually exists and come back and say your email address is invalid, because there's stuff out there that'll test your email address out. All right, so that is regular expressions in a nutshell. I think I wanted to cover that with you in a little video so you guys can see all that stuff that are here. So regular expressions are neat, and the reason why we want to use them is for validation, is what we want to use them for, more than anything else. I want to enter data, and I want to use validation. How do I use it with Java? One thing is to try it, and the other thing is to use it. We kind of poked around and tried to figure out what this does. And if I scroll up a little bit, it kind of told us, right, what to do in our strings. There is something called matches. And matches actually takes a regular expression. Does the string match the regular expression? And if the string matches, it's going to give us a true. If it doesn't match, it's going to give us a false. We can try this out with some stuff we've already entered in, right? For example, I need numeric data, right, for my for the stuff that I'm entering in right now. Okay, so I'm going to come back to this in a second. Let's suppose I go to this site again. One more thing we can try. So let's get rid of, we did this one. This is an email. I'm going to copy paste this for you guys. We did an email one together, and you should be able to puzzle out other ones. I recommend copying this thing because you might need something like this in the future. You can also look them up. If you say something like, I need a regular expression for email, as an example, or a 10-digit number, you can look that up. You can say regular expression, for 10-digit mobile number. There we go. In Java, right? And then you can look it up. Stack Overflow will nicely give you a regular expression or someplace like that where you might get a regular expression. Well, that's a 10-digit number, but that's not a phone number, right? 10-digit phone number. We're going to say phone number, right? And then maybe that'll give you something that makes more sense, right? So you can get a code example from somewhere that gives you something that is okay. I'm not sure this is the best site, but you can see that there's other ones out there. For example, Stack Overflow might have some examples of regular expressions that might work for you, and you should check them out. Do a little bit of inspection. Does this make sense for you if you were looking at this thing or not, right? And why are they asking for the things they're asking for? You should be able to look at this and have no problem understanding, for the most part, what it's doing. Okay, so that is something you can also do. And it's, of course, it will be allowed if I ask you for something on a test, or if I ask you for something somewhere else, then it's totally fine. Thank you for that, Guillermo. Very interesting and very detailed, right? I love it. For email address, you mean. So let's continue for this, right? So let's think about another one, right? And the last regular expression that I want you to use is for the number. So Guillermo has some. Let's see if we kind of take this out, and I want to use a floating point number. That's what I want, a floating point number, and I want to be able to test something like 0.0 or even something like 1, and both should compute, right? How do I test something like this or 55.3785? And all of them should be okay, but I cannot have anything like A, B, C in there, that's not going to work. This just should fail, ABC. Anything like A or A5.37, that should also fail, right? Because that's what we're testing. We're testing how this works. So what should I put in here? You try it now. What is the thing that I'm looking for to put in here so that 0.01 and 55.3785 work, but not these ones? What would I put in there? Let's start it off. What do you recommend? Help me out. Dots. I'm not sure if that's enough for email, Guillermo, because I'm not sure if it's detailed enough. But what about for this one? What do we do here? Try it out for you. By the way, the reason why I'm thinking that that's probably not good enough is because it's probably too broad, right? And we want some limitations. Some limitation. That's where it's really challenging. Emails are really hard. So let's try it out. So we want at least a numeric character, right? That's how it starts off. So we want at least a numeric character. So /D. We want at least that. Okay. So once we do this, it's like this computes, but the dot does not, right? Okay. Guillermo says /dot star and then /. Okay, I like that. And Kuhen kind of did the same thing. We said this, we need at least a character. So he put in brackets. Brackets mean, by the way, a subexpression. That's what that means. Subexpression and then plus. Remember what plus means? Plus means at least one and unlimited matches. And we want a number between a decimal number, some kind of number between 0 and 9, right? And so 1 or more. So far it's good. And then the second expression on the other side is some kind of dot, right, with a number, and we want unlimited 0 or more, right? So it covered this one, and this one, but it didn't cover ABC, thank God, and it didn't do this one. So pretty good. Would you agree? Let's try bigger numbers. Let's try negative 1000.0 to, negative numbers should also be covered, right? We should be able to cover negative numbers in our things, not just positive numbers, but negative numbers. So how do I do that? How do I modify what Kuhen or Nitin has suggested? Both of them are pretty good, actually. What else should we put in here? How can we include the dash as an option? Because it should be optional, the dash, right? How do I put that in there? You guys are pretty good, though. You're getting it. People who are trying anyway. /dash. Okay, let's try this out. But if I put /dash, that means it's required. If I put /dash, that means it must be there, right? If I say it's optional, that means it's another case. Think about these brackets as cases, right? Where it could be one or more could be there, right? But I want to say it could be it has to be, there can't be more than one, because that doesn't make sense. It's got to be exactly one, right? So it's almost like I want the dash, and if I do have this dash, let's say put this in square brackets, this is the character I'm looking for, and I want maximum 1, right? I don't want any more than 1, only 1, right? And it's got to be optional, right? Because if I have it, it's only got to be exactly 1, right? It can't be less than 1. Does that make sense? Yeah, question mark isn't bad either. That's also another option. But now it covers negative numbers and it covers all these numbers, right? But it doesn't cover this one. Any alpha character or any funny character. If I did something like 3 hashtag 98 dot, I don't know, question mark 554 or something like that, wouldn't work. It would just fail, right? Because those funny characters, special characters aren't included. Okay, but what about the dash character? If I say like 3-5 dots, 3-5 actually computes. 3-5 computes. Remember, like we want to make sure that things don't work. 3-5 shouldn't compute. That's actually incomplete. It should be wrong. So group 2, which is, this is the second capturing group, that works. Dash should not be included. There should not be included in the third capturing group, this part. So dash should be something that is excluded, all right? Look and see what Guillermo says. So Guillermo says a slash, which is only exactly 1, /D, /W. So W is alphanumeric, only 1, yeah, 1 or more. That's probably not going to be right. Plus 0 or none, plus dot, and a thing. Yeah. Well, we want to exclude stuff. We don't want to include certain characters. So the way to not include it, so /D is 0 to 9, 0 and dash and 9, a range of numbers, right? But what if I said something like, for the second capturing group, right, I can't have any dashes, and it says at least 1, 3, and then -5, right? Look at that. So 3 and -5 works okay, but it's almost like I want to say that this first part is together, right? This first part must be together if I'm going to do it. It's almost like I need to put brackets around brackets. So I want to do something like that looks like this. Brackets, brackets. And it says, well, this one is the, again, group 0. This is text, and this is the second capturing group. This is the first capturing group, right? And then it goes this one, which is group 2, and this one, which is group 3. So this is group 3. And I don't know how this sees this one as group 3, right, over here. But clearly, we can actually get this. So these are all right, but this is wrong. This is no good. Shouldn't be able to do that. So I can try that one if you want, Guillermo. But I wonder if, again, I'm just gonna copy paste there and see how it likes that. There's Guillermo's suggestion, but again, it captures this wrong part right here. So that can't be. Okay. So we want to be able to disqualify a dash. Only it's going to be at the front. Well, we can say that, remember? Let's undo again. Right? And what if I said that this part must be at the beginning? So I want to capture at the beginning for this part. And so remember that we can say that this part right here, this whole part, if I put caret inside brackets, like so, right? I want this part to be at the beginning, this part, right? So I can say this part's at the beginning, and this part is at the end, right? So if I said something like this, right, we're going to actually lose some of this stuff. This worked, but not this one, right? See how that kind of splits it off? This worked, and then this worked, but not this one, apparently. Right, so that's something we have to figure out. How do I capture a floating point number that doesn't include things? So let's look it up. That's what I would do. I'd say, regular expression for floating point numbers. So if I was going to look that up, again, you have to know what to look for. And it suggests something that looks like this, plus or minus question mark. So going back to the question mark, Nitin, you said question mark, right? And then 0 to 9 with 0 or more, 0 to 9s, right? With a dot, and this whole thing is 0 to 9. Oh, sorry, 0 to unlimited, and then followed by 0 to 9 plus. Let's try this out and see what happens. Okay, and then if you want to match 1, 2, 3 dot, no, with nothing else after it, would this be okay? Then they make another one. Let's try and see if there's another one for this one. So again, I'm talking about this because you guys should understand there's limitations on what we can do. Let's try this one. So this one says it's clearly not good because it also captures this one and it's okay. It captures this one, this one, this one, this one, and this one, but this one, it's wrong. Look at that, because it captures this one because 3 and then -5, both of them are good, right? Because you can have this this is an error that it captures. So that was the one we found on this one. Okay. So it says use dot instead of /dot and 0 to 9 instead of /d to avoid escaping issues in some languages like Java. See that? It tells you that. So let's go back to that part there. Just a momento. And let's go to this one. And it must have a dot, at least one dot character. This one means 0 to unlimited characters. And this one says matches the previous token between 0 and 1 times, right? So the previous thing here is 0 to 1, right? And this one says at least once. At least I have one 0 to 9. So I can have any of these here. Look, and it says this one is 0 and 1 time, between 0 and 1 time for the plus. So that's why it kind of covers these two things. If I take this one out, like we said, so if I was to take this part out, then you can see it doesn't cover the negative number, and it doesn't cover this one at all. So we got to figure it out where we want that negative only to be there in the beginning, right? So it's either a negative, like we want it in the beginning. Again, that kind of caret token only in the beginning, right? We want to have a sequence in the beginning that has a negative, right, character, so /dash, right? And notice that it captured this one, but none of the other ones. And we want to say at least, this should be at least, if it's going to happen, it's going to be optional, right? And it's going to capture at least 0 to whatever times. So 0 and 1 time, right? Which is 0 to 1. And that kind of does it, I think. Okay. So, I mean, again, little examples of how to do the same thing to capture floating point numbers. And why do we need this? Guys, we may use this today when it comes to entering data. If I want to validate my stuff, as an example, how do I validate my floating point numbers so that they're accurate, right? Well, remember what we had last day? We had it so that we're already capturing floating point numbers, but they're also allowing us to add in a D in there. We don't want that D to be added in, right? We want that D to be incorrect. All right, questions around anything around regular expressions? I think we've done them to death, in my opinion. I think we've gone above and beyond. We've spent a good hour on regular expressions alone, an hour and a bit. And I want to make sure that you guys are okay with it so that we can move on. Let's stop recording this one. Let's take a short break because it's 7:35, right, as an example. When we come back, so we'll come back at 7:45, 10 minutes, and we'll come back and we'll do the second part of our lecture today. All right, let's stop recording this one. All right, so we're not recording anymore.